Section 6.6, Rational Exponents. This is really a continuation of the exponent rules that we did back in Chapter 5. Now, the difference in Chapter 6 is we're going to include fractions in all these exponents, which we've seen already in some of these sections. Now, one thing that we've already talked about is how to take a fractional exponent and rewrite it, but let's just refresh on how we do that. So if we have a to the m over n power, we can rewrite that as a root like this. Okay, whatever's on the bottom, so in this case, n is in the denominator, right? We're taking the nth root of a. So we could really rewrite it as a to the 1 over n power, and then whatever's on the top, so in this case, m is the numerator, it's being raised to the m power. Okay, and when we have a fractional root like that, 1 over n, that really just means we have the nth root being raised to that m power. Okay, and it doesn't matter what order we write it in, like here we're taking the root first, and then we're raising it to the power. And then if we look at this one, we raise it to the power first, and then we take the root of that power. Okay? It doesn't matter. Both are going to give that same answer. Down here, we have a negative exponent. It's the same exact thing if we look at these steps over here. It's just that it's on the bottom of the fraction. So all those things that we learned about negative exponents and how it switches where it is in the fraction still apply. So let's say we have 4 to the 5 over 2 power. Looks complicated, but it's actually really simple if we know how to rewrite it. So let's change how this looks. Okay, whatever's on the bottom is the root, and whatever's on the top is the exponent. So this is 4 to the 5th power square rooted. Okay, we can also write it like this: square root of 4 to the 5th power. Now we want to be strategic about this and choose the one that's easier for us to do. I don't know what 4 to the 5th power is. I do know what the square root of 4 is. Square root of 4 is 2. Okay, so this becomes 2 to the 5th power, and this is easy enough to figure out because it's just 2 times 2 times 2 times 2 times 2. 32. Number 2, 81 to the 3/4 power. This is going to be the 4th root of 81 raised to the 3rd power. 4th root of 81, we would do a factor tree. We'd break it down. So 9 and 9, a bunch of 3's here. We would see there's 4 3's. So the 4th root of 81 is 3. Raise that to the 3rd power, and we get 27. Lastly, 1 to the 7th 8th power. 8th root of 1 to the 7th power. 8th root of 1 is just 1. Okay, because 1 times itself 8 times is still 1. And then 1 to the 8th power is still 1. All the exponent rules that we went over back in section 5.1 are exactly the same. So if we have a problem like this, where we have exponents raised to another exponent, we're just going to multiply them. So 1/3 times 3, that's going to give us x to the 1st power. 1/4 times 3, y to the 3/4 power. Right here we have two things that are multiplied, which means we're going to add these exponents. One thing that you guys like to do that's incorrect is you like to multiply these numbers, and that's not what we do. So for example, if we add x squared times x to the 5th, this equals x to the 7th. We don't change this x at all. It just stays the same. That's called the base. All we do is we add these exponents. So when we have 2 to the 3/4 times 2 to the 1/2, all we're going to do is add those exponents, keep the 2 the same. So 3/4 plus 1/2, give them a common denominator. So times 2, we get 2 over 4. 3 over 4 plus 2 over 4, 2 to the 5/4 power. Okay, number 6, we're dividing. This is 3 to the 1st power over 3 to the 1/4. We subtract these exponents and get 3 to the 3/4 power. Just like chapter 5, the questions get more complicated than that. Anytime we see a fraction inside parentheses, it's usually a good idea to simplify that fraction first. So when we look at this one, we see 20 to the 1/2 power, and that's a square root because we should recognize anything to the 1/2 power as being a square root. On the bottom, we have another 1/2 power, so this is really just the square root of 5. And when we have two roots that are the same, regardless of what they are, we can write it as a single square root. So this is just 20 over 5 inside a single square root. Okay, that becomes 4. It's the square root of 4 or 4 to the 1/2 power. When these are the same, you can just divide those two numbers. Okay, we know what the square root of 4 is. Okay, that's going to be 2. 2 cubed equals 8. And number 8 here, we can simplify these numbers. That's going to be a 2. X, we have a 1 on the top, 1/2 on the bottom. We're going to subtract those, and we're going to be left with a 1/2 on the top. Okay, Y's, we have 3/4 on the top and 1/2 on the bottom. So we're going to have to subtract these. Okay, so 3/4 minus 2/4 gives us 1/4. Negative exponents like we have in number 9 still go to the bottom of the fraction. So we would have 1 over x to the 3/5 power. Now this would really be the 5th root of x cubed. Okay, and that's not allowed because we're not allowed to have a root in the denominator, which means we need to get rid of that. And we're going to get rid of that by completing however many we're missing to make 5. All right, so we need another 2 x's. Right, and we're just going to finish out the fraction to make it total 1. Okay, so 3/5 plus 2/5 is going to give us that 1x on the bottom. And on the top, we would have x to the 2/5. Okay, you can write it like that, that's fine. Or you could switch that numerator to the 5th root of x squared. Lastly, we have a bunch of different exponent rules in this problem. So a to the 2/3 times a to the 1/4. We would add these fractions together. Okay, we want to have a common denominator. So times 4 over here, times 3. We get 8/12 plus 3/12, 11/12 for the a. Oops, 11/12 that is. All right, the b's. We have 5/4 on the top, 3/4 on the bottom. We're going to subtract them. Bigger b is on the top, and there's 2 more on the top. So 2/4, which we can simplify to 1/2. Right, the c's, we have 7 over 2 on the bottom, 1 over 2 on the top. Bigger one is on the bottom in this case. And there's 6 more halves on the bottom, 6 over 2, or 3 more on the bottom. Okay, so this answer simplifies to that set of variables.